Good morning. My name is Grant Kramer, and I am a professor emeritus at the University of Nevada, Reno. Are you passionate about wine as I am? Then you know that growing grapes, fermenting wine, and drinking that wine is good for the heart as well as the soul. And if you are interested in having some private consulting or direct contact with me, you can reach me at my new email address called drvinoinreno@gmail.com. I'll be happy to respond to you. The post-harvest winterization of grapevines is basically made up of three main tasks: irrigation, fertilization, and pruning. Post-harvest irrigation is a tricky subject, as there are different considerations that have to come into play here. After harvest, you want to irrigate at least once to stimulate the photosynthesis of the vine and encourage the production and storage of carbohydrates in the trunks and the roots that will be used later on in the spring when the grape buds break. Once the leaves have dropped, you may need to add one more irrigation to keep the soil moisture levels sufficient throughout the winter. The grapevines are in a dormant state during this period of time and do not require water. However, extreme drought could cause the roots to die back, and you don't want that to happen. However, you need to be very careful when you irrigate in the wintertime that there are no very low temperatures approaching your environment in that area, because the ground may freeze and split the trunks and damage your vines. Too much irrigation, however, can stimulate the vine growth, which will make the vines more susceptible to winter injury by delaying the induction of dormancy, preventing or slowing down the hardening off process. Too much irrigation can also make the vines susceptible to winter injury. And dehydrated vines, therefore, are more cold hardy. So here's a simple fact of a rather complicated process of cold hardiness. Where the ice crystals form in freezing temperatures in the cell is key to the survival of the vine. If the ice crystals form inside the cell, inside the plasma membrane will rupture, and this will kill or destroy the cell. If the ice crystals form outside the cell, outside the plasma membrane and in the cell wall, then the cell will generally survive, but it can become dehydrated. Solutes inside the cell, such as sugars and salts, help to lower the freezing point in the cytoplasm for these vines, and they can withstand lower temperatures. You know this by when you spread salt on roadways, you prevent the freezing of water, and it doesn't freeze until it reaches a lower temperature. Another factor involved here is a process called supercooling, in which temperatures that go below freezing temperatures do not form a solid ice crystal. And this is, again, a complicated process that I don't have time to go into. But suffice it to say that supercooling occurs due to a lack of ice nucleation centers, preventing the formation of ice. On the right here, you can see actual images of ice that have formed in leaves at low temperatures or in buds. And you can see that they form in specific areas, generally in this case in the apoplastic regions outside the cell, because amount of salts and sugars that are in this apoplastic space are much lower than the amount of salts or sugars that are inside the cell, and therefore the ice forms outside of the cell. However, at some point, the cells themselves will also freeze. And there are, again, many factors that are involved in this that I don't have time to go into detail. In its deepest dormancy state in the middle of winter, wine grapevines will be killed at about minus 10 degrees Fahrenheit or about minus 23 degrees centigrade. So let's speak a moment about vine dormancy, because vine dormancy is critical to cold hardiness. So vine dormancy starts in the fall and is a progression through the winter and reaches its deepest dormancy in the middle of the winter. So we say that the vines are acclimating to the colder temperatures and shorter day lengths in the fall and starting to deacclimate in the spring. The more dormant a vine, the more cold hardy it is. If you look up in the right-hand figure, you can see that the grapevine here is demonstrated by the buds in the summer are in a state of what is called paradormancy. This is a different state that inhibits the dormant nature of those buds, and water deficit helps to maintain that dormancy and prevent lateral shoots from breaking. Once we reach the fall, endodormancy begins, and this is signaled by short days and cold temperatures. And what do we mean by endodormancy? Endodormancy is a kind of dormancy that is controlled internally by plant signals such as hormones. At some point, we reach a stage of echodormancy, and this is dependent upon a chilling requirement by grapes above freezing temperatures of between 150 to 200 hours. And this then puts the vine into a state of echodormancy. And in this particular case, then water deficit actually promotes the development of echodormancy. In the endodormancy state, the vine buds will not break. They must get into the echodormancy for buds to break. Therefore, it's important to fulfill those chilling requirements. As the vine continues to deacclimate, then it will go into a stage where growth will start to occur, which we call bud break. And this usually happens when average day temperatures are at or above 50 degrees centigrade. So in the two figures here, we have one in the top, which is related specifically to grapevines and bud dormancy. And in the lower figure, we see another image of plants in general, again, discussing the different seasons and the different kinds of dormancy that exist and the factors that affect them. And you can see in this figure that endodormancy is regulated by physiological factors inside the plant and influenced by chilling responses and photoperiodic responses from the environment. As the plants are coming out of dormancy, this is affected by the temperatures. It can also be affected in general on plants in terms of the effect on nutrient deficiency and water stress. Post-harvest fertilization is another factor to consider. This is a particularly good time to fertilize your vines with potassium to replace the potassium that was lost in harvesting your grapes. The grapes have a high concentration of potassium, and each harvest time you're removing some of that potassium from the vines. Potassium is also important for enhancing cold tolerance during the winter and improving dehydration tolerance. It's not a good time to be adding nitrogen, as some people recommend, as this will promote growth in the vines and delay the dormancy, making it more susceptible to early fall frosts that may be occurring or freezes. This is also a time when other nutrients could be added if you know that these nutrients are deficient in your vine. Finally, winter pruning is the next step in consideration later on in the winter. Pruning should not be done unless the vines are fully dormant in midwinter. So it should be at least midwinter before you start to do your pruning. If you delay pruning, as I recommend in cold regions where you're susceptible to spring frost, this will delay bud break and help prevent it from breaking too early and being damaged by early spring frosts. Pruning should not be conducted when raining or is imminent in the next couple of days, as this will promote trunk diseases. As I mentioned before, bud break occurs when the average daily temperatures are at or above 50 degrees Fahrenheit or 10 degrees centigrade. So if you time your pruning just at bud break, you will get the maximum delay in bud break. This consideration is dependent upon how many vines you need to prune and whether you can do it within a reasonable amount of time. Those with very large vineyards may want to start their pruning a month or two before. As the winter is progressing and we are heading into early spring, you can get false springs where we have unusual warm-ups in the weather. And this will enhance the deacclimation of your vines and make them more susceptible to a subsequent cold event. So colder temperatures in the midwinter will not damage the vines, but those same temperatures could damage the vines in the spring because the vines are less cold hardy.
Well, that's it. I hope you enjoyed this video. If you like this video, then I encourage you to like my channel and subscribe to my YouTube channel, where you'll find other interesting videos like this one. Have a great day.